Hey you! Welcome to your Chapter 4, Lesson 5 notes on writing a function rule. By the end of the day, you'll be able to write equations that represent functions or represent any situation. It'll be great. But first, let's start out with a helpful hint of 3 steps for representing a situation with an equation. The first step is you want to figure out what you're dealing with. In math language, this is called identifying variables. So first you want to identify what two quantities are you working with? What's changing? What are we going to focus on? So identify your variables. The second step is to relate it to your situation. What else is going on? This is really hard to explain without actually looking at a situation, so I'll look at 3 to help you out. And then finally, you will write your equation. You're remembering that an equation is like a math sentence. So there you go. There's your 3 steps. If you're working in Notability, go ahead and copy those 3 steps because we are going to put them on each problem. Okay. In fact, I'm going to spread them out just a little bit. And here we go. So in our first example, it tells us that you can estimate the temperature, like the temperature outside, by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in a minute. What is the function rule that represents this situation? Well, what are we talking about? Well, we've got our outdoor temperature. So we're dealing with temperature, and that is more than 1/4 the number of chirps the cricket makes. The number of chirps the cricket makes. So those are our 2 variables. So let's say that T equals the temperature. And we'll say that chirps, actually let's do N for number of chirps. N is number of chirps per minute. Now, I claim that the temperature depends on the number of chirps. So temperature is dependent and the number of chirps is independent. And here's why. We've got this magic word is that's helping us out. The temperature is, and then that's followed by a description. So that tells us that the temperature is defined by the chirps. It's dependent on how many chirps we have. We start with chirps, that's our input, and then we get an output of a temperature. Okay, so what else do we know? It's 40 degrees more than 1/4 the number of chirps. Let's translate this, okay? There we go. Temperature is 40 degrees more than 1/4 of the chirps in a minute. Excellent. So now let's translate that into our equation. So we've got the temperature, T, is an equal sign. 40 degrees more than, so 40 plus 1/4 of the number of chirps. So that's chirps. 1/4 the number of chirps. Oh, we know that. That's N. Hey, we have it. That's literally the equation. T equals 40 plus 1/4 N. Ta-da! That's it. Let's do the next one. This one's for all your dog lovers out there, but before we go on, remember to copy your 3 steps. Put them down here. Okay. So a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Let's write a function rule for the total cost of N days of boarding plus a bath. Ooh, here we go. The total cost. The cost is going to depend on how long we stay there. So our variables are cost and days of bathing. How about we say like N is like the length of the stay or amount of time they stay. Length of the boarding stay. And we'll say C is cost. Okay, and we picked C as our dependent variable because cost depends on the number of days. So the question we're asking is, what is the cost of the days? Well, let's see. Okay, we know it is $15 per day. So that'll give us 15 times the length of our stay, the number of days we stay. Upon arrival, each dog must have a bath that costs $12. Ooh, so that's an additional $12 cost for our bath. So what's the cost in total? Well, the cost is equal to 15n, so 15 times the number of days we stay, plus 12 for our bath. There we go, that's our equation. Excellent. Okay, so how much does a 10-day stay cost? So the question is how much? What is the cost of a 10-day stay? So let's plug in 10 into our n, not because they rhyme, but because n represents the length of the stay. Okay, so we'll get rid of n, say that's 10. Let's see, what does that cost? Well, that's 150 plus 12, which is 162. So it costs $162 to have your dog stay there for 10 days. So does a 5-day stay cost half as much as a 10-day stay? Well, first of all, what is half of 162? 162 divided by 5 is, nope, just kidding, divided by 2, sorry, half. Divided by 2 is 81. So half of that is 81, okay, half as much as a 10-day stay is $81. So how much does a 5-day stay cost? Well, let's take our equation and let's plug in, this time, a 5-day stay in for n. 15 times 5 is 75, plus 12 gives us 87. So no, 87 is more than 81, which is half of a 10-day cost. So does a 5-day stay cost half as much? No, it's more. Well, why is it more? Because we don't take exactly a 10-day cost and divide by 2. We have a flat rate of 12, and then we add the per diem. Per diem means each day. So there you go. All right, our last example. So let's say you've got the area of a rectangle, and its length is 5 feet more than its width. What's the area when it's 9 feet? First, let's write a rule. Our steps here are to identify the variables. Okay, what do we need? Well, let's quick look at the area of a rectangle. Refresh to find the area of a rectangle. That's length times the width. So if you have this rectangle, length L, width W, the area is the space inside. Okay, so we have the length is 5 feet, just kidding. The length is 5 feet more than its width. Okay, so the variables that we're dealing with, let's say L is length. That was a really pretty way to write length. Good job, me. And W is width. Now, the way the question was explained, the way the problem is stated, length depends on the width because the length is defined by the width. The length is 5 feet. Sorry, I missed. The length is 5 feet more than the width. So to write our equation here, we say that length equals 5 plus our width. Cool. But you guys, that's only half the work. Because we don't really care what the length is. The question is really asking, what's the area? So let's redo our situation real quick. Let's take our area, and we don't know the length, but we don't need to. because we can take this whole expression right here and replace the length with that. Well, that was kind of a gross color combination, but we're going to go with it. So we're going to substitute that in for our length. So this time we have area equals 5 plus W, because that's our whole expression for our length from up here. We're going to take this, we took this guy and went right in there. 5 plus W. Also times W. So we don't need to know what our length is as long as we know what our width is. Ta-da! So that is actually our true equation. Area is 5 plus W times W. Now that we have this squared away, that would have been a pun, except we're dealing with rectangles. Let's solve our problem. The real question is, what is the area of the rectangle when the width is 9 feet? So we want to find out, okay, area and width is 9 feet. So if the width is 9, we're going to place all of our widths with 9. So area equals 5 plus 9 times 9. Well, let's solve it. 5 plus 9 is 14. 9 is 9. And by, hold on. I did my math wrong in my notes. So I need to quick do the calculation. Okay. 14 times 9. That's much better. Okay, equals 126. So our area is 126. Were we given length? We're given feet. Feet. We're given units. Feet. So area is 126 feet squared. There you have it. Excellent. Well, there you have it. 3 most important steps. Identify what you're dealing with, relate it to your situation, and then write your equation. Have a fantastic time on your homework.